Find the volume of the solid obtained by revolving the region bounded by y equals x cubed, y equals 8, and x equals 0 about the y-axis. Okay? So we're given something along the lines of kind of like this. This will be y equals x cubed. And then y equals 8, I'm going to say is right about here. So this will be y equals 8. This will be y equals x cubed. And then we're given x equals 0, which is the y-axis. And then we revolve it about the y-axis. So when we revolve it, we get a solid kind of like this. Yeah, that seems reasonable. So the easiest way to do this one would probably be the disk method. So we're going to have concentric? I guess it would be concentric. We'd have circles, basically circles stacked on top of each other. Delta y going up this way, where each of these is a circle. And so our integral will be from 0 to 8. So we have 0 to 8 of pi r squared delta y. And it's always kind of a good idea to look at this and make sure this is actually a volume. So you should have 3 elements of dimension. So you have r, which is a length, and r squared, so that's a length squared. And then you're multiplying that by delta y, which is also a length. So if this was measured in meters, you'd have a meter squared times a meter. That would give you meters cubed, which is a volume, which is nice. And so if you get something that's not a volume, then you're probably doing it wrong. Probably. So one of the tricks here then we're going to have to do is find out what this r is here. So pi r squared, the idea is this is the disk method. We have a whole bunch of disks and we stack them on top of each other. And they are of varying radii going up. And so we're going to define this radius as y, so we have y equals x cubed, r, so then this radius here will be, in terms of y, we'll rearrange this so that x equals y to the 1/3. So if you think of this radius here will just be the x value. So we want to put in, so the radius equals x, and x equals y to the 1/3, which is just this equation right here, rearranged. So now we have the radius, we have a delta y, and we can rewrite this then as 0 to 8, move the pi to the outside, we have a y to the 1/3. I should also find r squared, which will be y to the 2/3. And then we have, I'm going to convert the delta y to dy. I like to start out with delta y because it helps me visualize it, and then I like to move it over to a dy to be like, all right, I'm actually going to do the integral. This is more visual for me, while with the dy, that's more mathematical. So the idea is get the picture right, and then after you have the picture right, do the math. Okay, so we have pi integral y to the 2/3 dy. Do the math. We have pi y 2/3 plus 1, that becomes 5/3. But then we multiply by the reciprocal because that's the power rule for integrals. And now we solve it from 0 to 8. So let's see here, 3 pi over 5 times 8 to the 5/3. Okay, so I just happen to know that 2 to the 3rd equals 8. Therefore, 8 to the 1/3 will be 2. So this will equal 3 pi over 5, 2 to the 5th, which I am going to rewrite as 2 to the 3rd times 2 squared. I guess I probably could have separated that out into, yeah, that's fine. We're good here. We're good here. Okay. So we have 3 pi over 5 times 8 times 4. So let's see here. We got many pies. So we have 3 times 8 is 24. 24 times 4 is 80 plus 16, which is 96, over 5 pi. There we go. Huzzah. Good for us. Go team. Hope that's the right answer. Let's see if there's an answer like that. Haha, there is. Good for us. Always that little moment of truth. It's like, oh, did I make a terrible mistake? I don't know. Maybe, possibly. I still might be did, but it wasn't a terrible mistake. It was a reasonable mistake because they had a answer there just to accommodate my terrible mistake. Terrible, though not unreasonable. Okay, so to backtrack real quick, what happened here was this was a disk method volume of revolution. So we're given a graph, we're given a bounded region, a two-dimensional region. We take that two-dimensional region, we revolve it around, in this case, the y-axis, and we're given this kind of like, I don't know, it looks kind of like a bullet type thing. And we're kind of like a cup. That's okay. Something. This shape. We're given a shape. And we decided to use the disk method. And that basically means we're going to use small circles, pi r squared, times a thickness, delta y, and we're going to go from 0 to 8. And then we plug those in, we find out, we convert r into the appropriate value of y, where r is the radius, and we then solve the equation. Make it a little 8 up there. And after we do all the math, we ended up getting 96 pi over 5, and that's the answer. So thank you much. Go team. See you on the next problem.